Chapter 16, Think and Solve. The first one, we talk about radioactive decay causing the heating of the Earth, and this is why if the sun suddenly went out, we would still have heat, even though the Earth would start cooling off, I think, relatively quickly. Don't know for sure. But we'd have so if you have a 500 degrees Celsius increase in temperature, and it takes 800 joules per kilogram degrees Celsius as the specific heat. Let's just assume we have a kilogram, since the kilogram seems to be the unit that they keep using here. We have a kilogram of granite. Then the amount of energy it takes in order to heat it up 500 degrees would be the 800 times the 500 times the 1. So it's 1 kilogram, specific heat, I guess, MC delta T. So 1 kilogram times 800 joules per kilogram degrees Celsius times 500 degrees Celsius. And that gives you 400,000. So 400,000 gives you 400,000 joules of energy. Now, the rate at which the energy is being released by the radioactivity is 0.03 joules per kilogram per year. And so that means after 1 year, we have 0.03 joules of energy. Another year, another 0.03, so 0.06 after 2 years, and so on. So it's going to take quite a while in order to release the 400,000 joules of energy. And so to figure out how many years it's going to take, you would take that 400,000 and divide by the 0.03 joules per kilogram per year. And what you would end up with is, well, it comes out to 13.3 repeating million years. And so that's where it comes from. 37 is the Newton's law of cooling. This is the one I talked about, that you can do it the wrong way and get the correct answer. So it's unfortunate that he chose these numbers. So we have 25 degrees Celsius, and it cools. It goes from 75 to 50 degrees in 8 hours. So it possibly could lose 50 degrees Celsius. It loses 25, so it loses half of the possible temperature in 8 hours. And so it will lose half again in the remaining time. So now that it's 50 degrees Celsius and it possibly could lose 25, it's going to lose half of that, so it'll lose 12 and a half. I went through an example in class. I recommend you sort of go by that. But again, please be careful, because the number 25 shows up at least 3 times in this problem, and it's so easy to mess up here. So every 8 hours you're going to lose half of what is possible. So 75 to 50 to 37 and a half to whatever halfway between 37 and a half and 25 is. One thing we do need to comment is that we have a vacuum flask. One, to explain why it cools so slowly, but also vacuum flasks, the only ones I've ever seen, are small, and the room, we assume, is much bigger. We are assuming that any energy that is lost by the coffee, assume it's coffee, yeah, by the hot coffee is going to be spread out over the room, so the room does not change temperature. And that is an assumption that we have to do for Newton's law of cooling. Anyway, that's the Think and Solve for Chapter 16.